Welcome to the discussion of types of sets, that is next topic in the set theory. Types of sets: null sets, equal sets, subsets and universal set. Null set which contains no object or element at all. This is called an empty set and it is denoted with the blank flower brackets or else the symbol pi. Example for the null set is, that is, set of all positive integers less than 10 which are divisible by 11. That is, none of the element exists, so that we can categorize it under the null set. Next is equal set. Two sets A and B are said to be equal if they have precisely the same elements. Then we write A is equal to B. That is, if we write example, if you are going to consider set A is equal to 1, 2, 3, 4 and set B is equal to x, such that x is a positive integer with x square less than 20. So answer for both the things are one and the same. Here the set A will be having the elements 1, 2, 3, 4 and if you are going to consider those positive integers and its squares which is less than that of 20 is same as a set B, where is as set of set A, that is set B is equal to set A or set A is equal to set B. Moving on to that next type of set, that is subsets. Given two sets A and B, we say that A is a subset of B or A is contained in B. If every element of A is an element of B as well, if A contains an element which is not in B, then A is not a subset of B. Here we have to be very careful that in this point, that is, if A contains an element which is not in B, then A is not a subset of B. It is symbolically written as shown like this: A is the subset of B. Here the symbol stands for, this symbol stands for is a subset of or is contained in. This symbol stands for is a subset of or is contained in. So let's consider an example. Set A is equal to 1, 2, 3. Set B is equal to 1, 2, 3, 4, 5 and set C is equal to 2, 3, 5, 6. Here we observe that every element of A is in B, that is, elements which are present in set A, that is 1, 2, 3 are present in set B, that is 1, 2, 3, 4, 5. Both are present in the same, and set A contains an element, namely 1, which is not in C, that is, except 1, 2 and 3 is present in C. Okay, therefore we can say that A is the proper subset of, or A is a subset of B and A is not the subset of C. In the above example, we also observe that set B, which contains A as a subset, possesses elements that are not in A, namely 4 and 5. In such situation, we say that set A is properly contained in or is a proper subset of the B. Okay, if it is both are one and the same, then we can say that it is directly a subset. Otherwise, if this is the case, in the above example, what is the case? We observe that the set B, which contains A as a subset, possesses elements that are not in A, that is, which are those, namely 4 and 5. In such situation, we say that set A is properly contained in or is a proper subset of set B. Moving on to the next type of set is universal set. All sets we consider are subsets of certain set, that is universal set, which is denoted by U. This set U is called universal set, or the universe of discourse, or the universe for that discussion. And we are going to come across some consequences while discussing type of sets. That is, First one is every set is a subset of itself. Second point, two sets, if we consider two sets, set A and set B, and if we say that they are equal if and only if A is the proper subset of B and B is the proper subset of A. Third point, null set is a subset of every set A. It's not only A. If you are going to consider any of the set, that is null set is a subset of every set. For any sets A, B and C, if A is a subset of B and B is a subset of C, then A is the subset of C. Fifth point, for any sets A comma B comma C, if A is equal to B and B is equal to C, then obviously we can say that A is equal to C. Moving on to the next discussion, that is power set. Given a set A, suppose we construct the set consisting of all subsets of A. The set so contained or constructed is called power set of A and is denoted by P of A. Example, consider the set A is equal to A comma B. Check all the possible subsets of A. The possible subset of A are null set, comma, singleton set A, comma, singleton set B, comma, A. That is set A. Therefore, if you are going to write that in the form of power set, that is power set of set A, P of A is equal to, open the flower bracket, null and singleton set A, comma, singleton set B, comma, set A. This whole thing forms the power set as denoted over here.